and thank you very much for joining me. I, of course, added Factorio series, and in between episodes, we've set up a couple different separate unloading stations. Now, the reason we did that is because we have each train being loaded with a different raw material. As you can see here, we've got iron over here on the left and coal coming in here on the right. And so we set up these separate unloading stations so the trains can be unloaded and fed directly into where the material needs to go. We don't have to do any kind of sorting or filtering on the base. We just send the trains to the proper station and it unloads. We don't have to worry about it. So that's what this kind of stuff is here. Some of it's temporary and some of it's, not in its final form, but it does the job. It gets the raw materials in to where it needs to go. So unless there's anything we failed to talk about, I think we can head up to one of our outposts and talk about a neat little trick that you can do to load your trains a little more efficiently. I'm going to take this train. You want to take the train or a car?
Well, actually, I'm just noticing we have a backup of trains, so I was trying to facilitate this in a way that the trains can get into the track without having this backup, but I think I failed a little bit here. What I did is I put a secondary line here, but as we can see, the train is stuck here on this track, waiting. So I didn't give it a way to get over. So that's something we'll probably remedy here in a bit, but I don't know if I have the track space to do it. So I'll just have to keep in mind that's something I need to fix.
Yeah, basically what we've done kind of foolishly is put this unloading station at the only input to this entire region, this entire little space here. So just as is happening right now, if there's a train stopped at this station and waiting to unload, the next train can't pass it because there's no bypass track. This is the only way it can get in. So not the ideal way of setting up our unloading station. And at some point in the near future, we'll probably go through and kind of reformat this whole area so it's a little more efficient.
Yeah, we were running desperately low on coal, so we kind of had to do this quick and dirty, unfortunately. As a matter of fact, we probably could send the train on its way, so because we are backed up here on coal.
I'm actually, so I'm going to ride it because that's where we're going to talk about our next topic. I welcome you to get in the other locomotive if you want, and we can head up there.
Oh, yeah.
And off we go. So now you'll see as this one leaves, the other one will have the space, the clearance to go in. It remains on screen before. So when we get there, what we're going to talk a little bit about are a new item called combinators that we haven't actually talked about yet. And they can get really complicated, so I'm going to start with just kind of some basic things. And I'm going to start with, so they're in use here, but we'll talk about that in a minute. We're going to start with the basics down here. And the combinator is this 2x1 item here with the greater than sign on it. And they pretty much do what you tell them to do. So here, obviously, we have what's called a decider combinator, as it says. And if you click on it, you'll see what you're asking it to do. You'll see a section called parameters, a blank space, an operand, and an output, or the output section. So basically what you're doing here is you're saying, if you click on parameters, you can pick in the game world. So you can say, transport belt greater than some constant or some other thing. For now, let's just go with a constant, and I'll just say transport belt greater. I'll set it to 10, and I'll hit set. Now that's like the evaluation that it is performing. Now, when you output, you can have two options. You can output 1, or you can output the input count. So if you're outputting 1, you pick a signal for it to output. So again, you can pick any of these items. You can say, blueprints. And you can say output 1 blueprint if the transport belt is greater than 10. So that's basically, as it's set up right now, that's what we'd be doing. And I don't know, can that set up the way it is?
I can see it if I can see what you set up.
Okay, good. So now the output will be coming out output line. It's helpful if you have the alt info on, you can see kind of. So the output line will be coming out, and I've just wired up this little light bulb, and this is all done with the green and red wiring. I've done just green at this point, but you can do any of this with green and red wiring, and this is how you kind of interact with all of these things. So you'll see the input is connected to this box, and then the output is connected to this light. Now, because we've set the thing to output a blueprint signal, I'm going to click on the light now, and you'll see mode of operation, enable, disable, use colors. You can check. It's just kind of yes, use colors or not. And we'll talk about that later. But then you'll see enabled condition. And I'm going to say enable if, where are they? Blueprints here. I can find, there we go, blueprints greater than 0. So if the combinator outputs blueprint of 1, meaning it's true, then the light will light up because I've told the light to light up if blueprints are greater than 0. So now obviously it's not lit up because there's nothing in this box. So the combinator is looking for transport belt and it finds 0 transport belt. So 0 is not greater than 10. So it's not going to output anything. No blueprints, no anything else. The output is nothing. And because the output is nothing, the light is not lit up. If I put a bunch of transport belt in here, you'll see the light now turns on. So the combinator is saying, I'm detecting transport belt. Transport belt, the number of transport belts I've detected is greater than 10. So I'm going to output 1 blueprint on my output signal. And then the light is looking at blueprint and it says the input, which I'm getting is 1 blueprint, is greater than 0. So I'm going to turn on. And that's kind of a simple explanation of how these combinators work. It's pretty much you can check things that go on and turn things on or off or control how things operate via your signal network.
So the blueprint is not a physical item. It's just a signal it's sending, more or less.
Right. And this can get a little confusing because you can use physical items. Now I'm going to put another box here and let's see. I'm going to make myself a blueprint and I'm going to put that blueprint in this box. And I'm going to wire this blueprint to the lamp as well. And a useful thing to do is to wire, if you wire anything to a pole, you can then hover over the pole and see what that wire is carrying. So if you hover over the pole now, you'll see signals to blueprints.
Mm-hmm.
So when the combinator is outputting 1 blueprint, it's just using the blueprint as a signal. You're just, like you said, it's not a physical thing. It's just saying 1 blueprint as a signal. Mm-hmm. But because it is a physical thing, it can be added to something else. So this second box that has 1 blueprint in it is also outputting a signal of 1 blueprint. And when you connect 2 signals together with the same type, they get added. So that's why our signal now has 2 blueprints, because we have 1 coming from the combinator and 1 coming from the box. That makes sense?
Mm-hmm.
So it can get a little confusing. There's also what you can do in the output tab of the combinator is all signals instead. So you can output, like, I just changed it to T. So now it's outputting something that's obviously not a physical entity. So that helps things. You can, be a little less confusing that way to say,
okay,
there's no way this T is going to be added to something else because there's no such thing as a T item. So that's a little bit helpful. And now if you hover over the pole, you'll see on our signal, you'll get a T and a blue blueprint. You'll also notice that the light is still on because it's getting the blueprint signal now from the box instead of from the combinator. If I take the box away, the light is still looking for blueprint. And even though the combinator signal is outputting, it's now outputting a T instead of a blueprint. So the light is not lighting up. It doesn't find any blueprints. All of that makes sense.
Okay, so the use colors thing, I'm not exactly sure how that works, but I'm not going to worry about it.
Well, so the use colors, let's see. Let me see if I can make Okay, so here we go. I can make an item to show the used colors. It'll just take a second till it manufactures. There we go. So this other thing is a constant combinator. And a constant combinator is, it's kind of a funny name. It basically just manufactures a signal of whatever you want. So you don't have to put transport belt in it to get a transport belt signal. You just tell it to output, transport belt or whatever you want. But on the signals page, the last page of the signals, you can see a bunch of boxes. You'll see all the letters, 0 through 9, and then A through Z, and then a bunch of colors. You got red, blue, green, all these other colors. If you pick one of those colors, like I just picked, well, yeah, green, and then you wire it to the light, and we click the used colors box in the light, it will use that color.
Oh, okay.
So that's kind of just how you get colors. If you output a red and a green, so you'll see now it's red and green, it takes the red because on the signals page, it always takes the leftmost color and overrides all the other colors. So if I want black, I have to make sure there are no other colors in this output box. I'd have to clear the red and green. And now, actually, I guess it doesn't output black because I don't know how a light would output black, but maybe a gray. Let's see if it'll do gray. No, maybe not. Cyan. I guess so. I guess cyan is the, I don't know, farthest right color you can actually access and have a light use. But then I can just start adding all these other ones and it'll just override because I'm moving left along the color tree. So that's how you get colors. And people have made all kinds of crazy colors. And I think somebody once made a Rick Roll like music video using combinators, and people get crazy with this kind of stuff. But this is the basics.
Okay.
Now does that make sense?
Yeah, I think so.
Okay, so the basics are pretty simple. I will, just to be complete, I'll show you the other type of combinator, which is called the arithmetic combinator. And instead of doing evaluations like greater than, less than, all of these things that show up in the evaluation of the decider combinator, this one, as it might say, does arithmetic: divide by, multiply, plus, minus, percent. I don't actually know what that, maybe that is. I'm not sure what percent is. It looks like it can even do power. So you have all these different things that it can do. And that's just another way of performing operations. You can write logic. You can really, I guess technically it's a form of coding with all the operations you can do. Now this is one of the probably more common applications of it. Now this will get really complicated, but in reality, the idea is pretty simple. So this one, you might actually want to turn your alt info off so you can see how the actual wires are going here. So what I've done is I've used a green wire and I've connected all the chests to each other. So I just are running straight up, connecting all the chests to all the other chests and nothing else. And that goes to the input of this decider or arithmetic combinator. So when I've connected all of these chests together, it's just adding everything in the chest onto the green wire. So I'm going to go ahead and make myself some more green wire, and I'll connect. Oh man, making green wire takes a while. Okay, here we go. So I'll connect this input to the pole so we can see what it says. So it says 51,000 coal. And that is the total of all the coal in all the boxes. 51,000 coal in all these boxes. Now, what I've done with the output is I've divided everything by minus 24. So I'm dividing 51,000 by minus 24 to give me the average number of coal per box, because there are 24 boxes. So the sum divided by the number of boxes, that gives me the average number of coal per box. And then I ran that output and connected it to every single inserter here. All these fast inserters have the input to the inserter coming from the output of this combinator, so that average. And if we hover over the combinator, you can see output signals minus 2.2 thousand. So that is what each inserter is getting. Now,
Wait,
each inserter
where's that?
is wired.
I'm sorry.
So if you hover, Yeah, it gets a little complicated. So if you hover your arithmetic combinator, you can see the input and output signals. So you'll see 54,000 input and minus 2.2 thousand output.
Unfortunately, I can't
See
see
that?
that because my HUD is blocking it with the way things
Oh,
are
interesting.
in this game. Yeah, for some reason my mini map is rather large, and when I hover over, the little window that pops up is like almost off the screen at the bottom. So the last thing
Oh,
I can make
wow.
out is energy consumption. Everything else gets hidden behind my, yeah, my little toolbar with the tools and stuff.
Huh. Okay, well, I guess you'll have to trust me. um,
It could be something that
yeah,
has
that'll.
to do with my text scaling for my screen. I don't know. I don't know how this game handles that.
Yeah, that does sound like, yeah, like a UI scaling. That sounds like it.
Uh huh.
Well, I guess the point is it is outputting the negative average of all of the colon per box,
Okay.
which right now is minus 2.3. So each inserter has knowledge of the average in every box or the average of all the boxes.
Mm-hmm.
It also knows what is in kind of its own box. And that's, if you zoom in all the way, you'll see a little tiny red wire connecting an inserter to its box. It's a little tiny thing.
Yeah, I see it.
So that is, yeah. So it's a red wire to make sure. We were talking before about how signals, if they're on the same wire, they'll add. So I didn't want this. I wanted the red network to be different from the green network because I want the box to the inserter to not add with the other signal coming from the combinator.
Okay.
So it's a different color. So now if we click on one of the inserters, we can say in the enabled condition, we say if everything is less than 0. Oh, wait a minute. I do want them to be added. That's right. So I explained that a little bit. Let me go back. I want the signals to be added because I want the amount in the box to be added to the average. And if the amount in the box added to the average is negative, that means the average is a larger number because the average is a big negative number. So that means the box has less than the average in it. I realize I didn't quite explain that correctly, but did my second attempt make any sense?
All right, I have questions for you, but I'm holding them until the end of the end.
Okay, so basically what I'm doing here is I'm saying, what is the average of all the boxes? What's the average that's in each box?
Mm-hmm.
And that's on the green wire going into the inserters.
Mm-hmm.
Then I'm making that negative. I'm adding to that the number of the amount in each box. So if the average is a larger number, a bigger absolute value,
Mm-hmm.
then the amount in each box will not surpass it, and the overall number will still be negative. And so that is when the inserter is enabled, because you want to add more to that box if the amount in the box is less than the average.
Okay. So okay. So what I'm understanding then is the whole purpose of this is to make it so every box is more or less being loaded at the same speed, or
Exactly.
the same
So
amount.
if one
Okay.
box, yeah, so if one box has a ton of coal in it and other boxes don't, you don't want to load that first box anymore. You want all
Mm-hmm.
until they're about even with it, and then all of them load up about evenly.
Okay. Yeah. Okay. I understand that. I think.
Yeah. So that's a general objective, and this is one of the more common things that at least I've seen these combinators used for. It's kind of complicated as evidenced by my first attempt of explaining it, but it's a useful, I think, demonstration of things you can do, little problems you can solve, because you can imagine if you have a stream of coal coming in and the first box just loads it all up, and then the other boxes don't get them. you're going to unevenly load your wagons, and then your train is going to have to sit there a little bit longer until everything gets loaded up. So it's just like one of those little solutions that this game kind of fosters, where you don't have to and it'll get done. But if you really want to dig into the nitty gritty and kind of fiddle with it, you can make these really cool solutions. And that's basically what Combinator's for. You can play the whole game without ever using them, or you can really get in and start fiddling with the features and making really fancy signal network things, and you can do that. Any other questions about signal networks, combinators? We'll get into it probably a little bit later, just as I'll use them for this and that. I'm not really into them all the time, but I like to use them sometimes. But they kind of make sense.
Yeah, I think so. So would you recommend having this on the offloading stations too? Or do you think that would not be useful?
I generally don't.
Okay.
Because I just kind of... Actually, that's a good question. I generally don't, but you could set up something similar. So you're trying to make sure you don't backload one particular branch and then one wagon can't unload. You certainly could. Yeah, you certainly could do this on offloading stations. I guess the question was, what do I recommend it? I don't know, maybe. I haven't done it before, but it seems like one of those things that could find a good use. So yeah, maybe I do.
Okay. Well, it looks like we're...
All right, well...
I was going to say we're at the end of the video.
We're a little over time, but yeah. So I hope this was a little bit interesting, a little introduction into combinators, and like I said, we'll get back to them a little later in the series. But until then, my name has been Rotype. He's been Mouse Gunner. Thank you all very much for watching, and we'll see you next time.